The geology of New Zealand is noted for its volcanic activity, earthquakes and geothermal areas because of its position on the boundary of the Australian Plate and Pacific Plates. Much of the basement rock of New Zealand was once part of the supercontinent of Gondwana, along with South America, Africa, Madagascar, India, Antarctica and Australia. The rocks that now form the continent of Zealandia were nestled between eastern Australia and western Antarctica. Basement rocks. The oldest rocks in New Zealand date from mid-Cambrian times, although there are older rocks in the Auckland Islands. The lower rocks are divided into the Western Province, consisting mainly of granite and gneiss, and an Eastern Province, consisting mainly of greywacke and schist. The provinces are further divided into terranes, large slices of crust with different geological histories that have been brought together by tectonic activity to form New Zealand. The Plutonic basement rocks are subdivided into the Ho'onus, Karama, Median and Paparoa batholiths that solidified from magma deep in the crust. These rocks formed the foundations beneath offshore Taranaki and the west coast Buller, northwest Nelson, Fiordland and Stewart Island. Most New Zealand granites were formed in Devonian Carboniferous time and Jurassic Cretaceous time. The rocks can be matched to similar rocks in eastern Australia. The sedimentary basement rocks are subdivided into the Western Province Buller and Takak terranes, and the Eastern Province Brook Street, Murihiku, Maitai, Caples, Torlesa composite and Waipapa composite terranes. The Western Province sedimentary rocks formed the foundations beneath the northwestern portion of the South Island, to the west of the Alpine Fault and Fiordland. The Eastern Province sedimentary rocks formed the foundation for the rest of New Zealand. They are mostly composed of greywacke together with argillite. The Alpine Fault that corresponds to the line of the Southern Alps has separated the basement rocks that used to be adjacent by about 460 kilometers. For example, Nelson and Southland used to be adjacent, as were Marlborough and Otago. In general, the sedimentary basement terranes become younger from west to east across the country, as the newer terranes were scraped off the subducting Paleo-Pacific Plate, and accreted to the boundary of Gondwana over hundreds of millions of years. The Buller and Takaki terranes of the Western Province formed in Cambrian Devonian time and contain New Zealand's oldest greywacke. The median batholith represents a long-lived batholith dividing the western and eastern provinces, and before the separation of Gondwana, stretched from Queensland through what is now New Zealand into West Antarctica. It marks the site of a former subduction zone on the edge of Gondwana. The Central Arc terranes are of Carboniferous Jurassic age and are believed to be related to ancient volcanic arcs. They contain sandstone and mudstone derived from volcanic rock and some limestone. The Brook Street terrain contains Glossopteris fossils linking New Zealand to Gondwana. The Maitai terrain includes the Dun Mountain ophiolite belt, which contains dark serpentinized ultramafic rocks. These rocks form a line throughout the length of the country that can be detected by the magnetic anomaly it produces. Ophiolites are slices of oceanic crust and magma that have been detached from a subducting plate and abducted onto the continental crust above the subduction zone. The Caples, Torlesa composite and Waipapa composite terranes formed in Carboniferous Cretaceous time. Much of the rocks were deposited as submarine fans. They have different origins, as shown by different chemical compositions and different fossils. Many rocks in the Western Province have been metamorphosed into gneiss. Many rocks in the Eastern Province have been metamorphosed into schist, due to exposure to high pressures and temperatures. Rocks grade continuously from greywacke to high-grade schist. Refer to the GNS map of New Zealand's geological foundations. Separation from Gondwana. New Zealand and New Caledonia represent the visible part of a portion of continental crust, usually referred to as Zealandia. The rest of Zealandia includes the Challenger Plateau and Lord Howe Rise, which stretch from northwest of New Zealand almost to northern Australia, and the Campbell Plateau and Chatham Rise, to the southeast of New Zealand. The Australia-New Zealand continental fragment of Gondwana split from the rest of Gondwana in the late Cretaceous time. Then around 83 March, Zealandia started to separate from Australia, forming the Tasman Sea, initially separating from the south. By 75 March, Zealandia was essentially separate from Australia and Antarctica, although only shallow seas might have separated Zealandia and Australia in the north. The land masses continued to separate until early Eocene times. The Tasman Sea and part of Zealandia then locked together with Australia to form the Australian Plate, and a new plate boundary was created between the Australian Plate and Pacific Plate. Zealandia ended up at a pivot point between the Pacific and Australian plates, with spreading in the south and convergence in the north, where the Pacific Plate was subducted beneath the Australian Plate. A precursor to the Kermadec arc was created. The convergent part of the plate boundary propagated through Zealandia from the north, eventually forming a proto-Alpine fault in Miocene times. The various ridges and basins north of New Zealand relate to previous positions of the plate boundary. Astride a plate boundary, New Zealand is currently astride the convergent boundary between the Pacific and Australian plates. The Pacific Plate is subducted beneath the Australian Plate from around Samoa and Tonga in the north, through the Tonga Trench, Kermadec Trench, and Ikurangi Trough to the east of the North Island of New Zealand, down to Cook Strait and the Marlborough Sounds and Kaikoura region. Through most of the South Island, the plates slide past each other, with slight abduction of the Pacific Plate over the Australian Plate, forming the Alpine Fault and Southern Alps. From Fiordland south, the Australian Plate subducts under the Pacific Plate, forming the Pushiga Trench. Over time, the position of the plate boundary has altered. Around 23 March, the convergent plate boundary formed Northland. Around 10 March, the Coromandel Ranges were formed. Activity has now moved further east, generating the Kermadec Ridge and Trench, and the Taupo volcanic zone. The Southern Alps are quite recent, only forming in the last 10 million years. Land movement. Because New Zealand straddles a plate boundary, it is tectonically active. The Pacific Plate is colliding with the Australian Plate at a rate of about 40 mm a year. The east coast of the North Island is being compressed and lifted by this collision, producing the North Island and Marlborough Fault systems. The east coast of the North Island is also rotating clockwise, relative to Northland, Auckland and Taranaki, stretching the Bay of Plenty, and producing the Hauraki Rift and Taupo volcanic zone. The east coast of the South Island is sliding obliquely towards the Alpine Fault, relative to Westland, causing the Southern Alps to rise about 10 mm a year. The Hauraki Plains, Hamilton, Bay of Plenty, Marlborough Sounds, and Christchurch are sinking. The Marlborough Sounds are known for the sunken mountain ranges. As Wellington rises and Marlborough sinks, Cook Strait is being shifted further south. Earthquakes. Deep earthquakes originate in the subducted plate. Because the Pacific Plate is subducting under the eastern side of the North Island, there are frequent deep earthquakes east of a line from the Bay of Plenty to Nelson, with the earthquakes being deeper to the west and shallower to the east. Because the Australian Plate is subducting under the Pacific Plate in Fiordland, there are frequent deep earthquakes near Fiordland, with the earthquakes being deeper to the east and shallower near the west. There are few deep earthquakes along the Southern Alps, because the two sides largely slide past each other. Shallow earthquakes are caused by stresses in the top plate. Shallow earthquakes are more widespread, occurring almost everywhere throughout New Zealand. However, Northland, Waikato, and Otago are relatively stable. Canterbury had been without a major earthquake in recorded history until the M7.1 Canterbury earthquake on the 4th of September 2010. A map showing the distribution of earthquakes in New Zealand can be obtained from Te Ara Encyclopedia of New Zealand. Current earthquake and volcanic activity can be obtained from the GeoNet website. Northland and East Cape Alexthins. An alexthon is land that formed elsewhere, and slid on top of other land. Much of the land of Northland and East Cape were created in this manner. Around 25 to 22 March, Northland and East Cape were adjacent with East Cape near Whangarei. Northland East Cape was an undersea basin. Much of the land that now forms Northland East Cape was higher land to the northeast. The Pacific-Australian plate boundary was further to the northeast, with the Pacific plate subducting under the Australian plate. Layers of rocks were peeled off the higher land, from the top down, and slid southwest under the influence of gravity, to be stacked the right way up, but in reverse order. The last rocks to be slid across were slabs of oceanic crust, mainly basalt. Widespread volcanic activity also occurred, and is intermixed with the foreign rocks. East Cape was later separated from Northland and moved further south and east to its present position. Sedimentary basins. Much of New Zealand was low-lying around mid-Eocene-Oligocene times. Swamps became widespread, forming coal. The land subsided further, and marine organisms produced limestone deposits. Limestone of Oligocene early Miocene age formed in many areas, including the King Country, known for the Waitomo glowworm cave. In the South Island, limestone is present in Buller, Nelson, and the West Coast, including the Pancake Rocks at Punakaiki in Oligocene early Miocene times. Many of New Zealand's limestone deposits were formed in relatively cool seas. Volcanic activity. When a plate is subducted under another plate, it causes melting in the mantle, the layer of the earth below the crust, and produces a volcanic arc, composed of mainly andesitic and rhyolitic volcanoes in New Zealand, but often widely varying in composition depending on the type of island arc. Andesitic eruptions tend to form steep stratovolcanoes, including mountains such as Ruapehu, Tongariro and Taranaki, islands such as Little Barrier, White and Raoul Islands, or submarine seamounts like Monowai Seamound. Rhyolitic eruptions with large amounts of water tend to cause violent eruptions, producing calderas such as Lake Taupo and Lake Rotorua. Basaltic volcanoes tend to form at intraplate hot spots. Basaltic eruptions tend to be fairly placid, producing scoria cones and lava flows, such as the volcanic cones in the Auckland volcanic field. Although Mount Tarawera's violent 1886 eruption was an exception. The South Island has no currently active volcanoes. However, in the late Cretaceous, there was widespread volcanic activity in Marlborough, West Coast, Canterbury and Otago, and in Eocene times, there was volcanic activity in Oamaru. The most well-known Miocene volcanic centers of the Otago and Banks Peninsulas. The Otago Peninsula near Dunedin was built up by a series of mainly basaltic intraplate volcanic eruptions in Miocene times. This has resulted in the formation of Port Chalmers. Banks Peninsula near Christchurch was built from two mainly basaltic intraplate volcanoes in Miocene times, corresponding to the Littleton and Akaroa harbors. Southland Solander Islands were active around 1 to 2 million years ago. The North Island is home to both old and currently active volcanoes. Over time, volcanic activity has moved south and east as the plate boundary moved eastward, and the place where subduction changed from the Pacific Plate to the Australian Plate moved south. A volcanic arc became active to the west of the current land in Northland in Miocene times, and gradually moved south down to New Plymouth, where Taranaki is still active. It produced mainly andesitic stratovolcanoes. The Northland Volcanoes include the volcanoes that produced the Waipoua Plateau and Kaipara Volcano. The Waitakere volcano has mainly been eroded, but conglomerate from the volcano forms the Waitakere Ranges, and produced most of the material that makes up the Waitemata sandstones and mudstones. Lavas produced the coarser Parnell grit. Notable visible volcanoes in the Waikato include Karioi and Piromia. Taranaki is a perfectly formed andesitic stratovolcano that last erupted in 1755. The volcanoes off the west coast of the North Island, together with Taranaki and the Tongariro Volcanic Center, are responsible for the black iron sand on many of the beaches between Taranaki and Auckland. Shortly after, a volcanic arc developed further east to create the Coromandel Ranges and Undersea Colville Ridge. The initial activity was andesitic, but later became rhyolitic. In the Kauairanga Valley, volcanic plugs remain, as does a lava lake that now forms the top of Table Mountain. Active geothermal systems, similar to those that now exist near Rotorua, were present around 6 Ma, and produced the gold and silver deposits that were later mined in the Coromandel Gold Rush. Later, volcanic activity moved further south to form the Kaimai Range. After this, activity shifted further east to the Taupo volcanic zone, which runs from the Tongariro Volcanic Center, through Taupo, Rotorua, and out to sea to form the Kermadec Ridge. Activity was initiated around 2 Ma and continues to this day. The Tongariro Volcanic Center is composed of andesitic volcanoes, while the areas around Taupo and Rotorua are largely rhyolitic. The Tongariro Volcanic Center developed over the last 275,000 years and contains the active andesitic volcanic cones of Ruapehu, Tongariro, and Nauruhoi. Ruapehu erupts about once a decade, and while the eruptions cause havoc for skiers, plane flights and hydroelectric dams, the eruptions are relatively minor. However, the sudden collapse of the crater wall caused major problems when it generated a lava in 1953 that destroyed a rail bridge, and caused 151 deaths at Tangiwai. The last significant eruption was 1995–96. Nauruhoi last erupted 1973–75. Lake Taupo, the largest lake in the North Island, is a volcanic caldera, responsible for rhyolitic eruptions about once every 1,000 years. The largest eruption in the last 65,000 years was the cataclysmic Aroanui eruption 26,500 years ago, producing 530 cubic kilometers of magma. The most recent eruption, around 233 AD, was also a major event, the biggest eruption worldwide in the last 5,000 years. The eruption caused a pyroclastic flow that devastated the land from Waiuru to Rotorua in 10 minutes. The Okataina Volcanic Center, to the east of Rotorua, is also responsible for major cataclysmic rhyolitic eruptions. The last eruption of Tarawera and Lake Rotomahana in 1886 was a relatively minor eruption, which destroyed the famous pink and white terraces, and covered much of the surrounding countryside in ash, killing over 100 people. Many lakes around Rotorua are calderas from rheolitic eruptions. For example, Lake Rotorua erupted around 13,500 years ago. Earlier eruptions between Taupo and Rotorua around 1.25 Mart and 1 Mart were large enough to produce an ignimbrite sheet that reached Auckland, Napier, and Gisborne. Vast pumice deposits generated from eruptions in the Taupo volcanic zone occur throughout the central North Island, Bay of Plenty, Waikato, King Country and Wanganui regions. Every so often, there are swarms of earthquakes within an area of the Taupo volcanic zone, which last for years. These earthquake swarms indicate that some movement of magma is occurring below the surface. While they have not resulted in an eruption in recent times, there is always the potential for a new volcano to be created, or a dormant volcano to come to life. White Island, in the Bay of Plenty, is a very active and acidic volcano, erupting with great frequency. It has the potential to cause a tsunami in the Bay of Plenty, as does the dormant Mare Island volcano. A line of undersea volcanoes extends out along the Kermadec Ridge. Intraplate basaltic volcanic eruptions occurred near the Bay of Islands in Northland in the late Miocene, and again more recently. The South Auckland volcanic field was active in Pleistocene times. The Auckland volcanic field started around 250,000 years ago, and is still active. It includes around 50 distinct eruptions, with most of the prominent cones formed in the last 30,000 years, and the most recent eruption, which formed Rangitoto Island, around 600 years ago. Geothermal activity. The Taupo volcanic zone is known for its geothermal activity. For example, Rotorua and the surrounding area have many areas with geysers, silica terraces, fumaroles, mud pools, hot springs, etc. Notable geothermal areas include Whakariwariwa, Tikiteri, Waimongu, Waiotapu, craters of the Moon and Araki Koroko. Geothermal energy is used to generate electricity at Wairaki, near Taupo. Hot pools abound throughout New Zealand. New Zealand in the last glacial maximum. Throughout the last glacial maximum, global sea levels were about 130 meters lower than present levels. When this happened, North Island, South Island, and Stewart Island were joined together. Temperatures dropped by about 4 to 5 degrees Celsius. Much of the southern Alps and Fiordland were glaciated, but the rest of New Zealand was largely ice-free. The land to the north of Hamilton was forested, but much of the rest of New Zealand was covered in grass or shrubs. Geological hazards. New Zealand suffers from many natural hazards, including earthquakes, volcanic and hydrothermal eruptions, tsunamis, landslides, and floods. The most severe earthquake was AM 8.2 event in the Wairarapa in 1855, and the most deaths in AM 7.8 earthquake in Hawke's Bay in 1931. Widespread property damage was caused by the 2010 Canterbury earthquake, which measured 7.1. The M6.3 aftershock of the 22nd of February 2011 resulted in 185 fatalities. Earthquakes along the east coast of the North Island have the potential to cause tsunami, as do earthquakes in South America. The most severe eruption since European times is the Tarawera eruption in 1886. However, there are many potentially dangerous volcanoes in the Taupo volcanic zone. Even a minor eruption at Ruapehu could cause the loss of electricity for Auckland, due to ash on the power lines, and in the Waikato River. Much of the North Island is steep, and composed of soft mudstone known as papa, that easily generates landslides. Parts of New Zealand, especially Northland, Coromandel Peninsula, Bay of Plenty, Gisborne, and the Manawatu can have high rainfall that can generate flooding of farmland. Geological maps. Geological maps of New Zealand can be obtained from GNS Science, a New Zealand government research institute. Notable geologists. Charles Fleming established the Wanganui Basin as a classic site for studying past sea levels and climates. Julius von Haast, a German geologist who traveled to New Zealand in 1858, made a study of the geology in some areas of the South Island. James Hector, an early New Zealand geologist. Ferdinand von Hochstetter established geological science in New Zealand. Patrick Marshall, also a zoologist, coined the terms andesiteline and ignimbrite. Harold Wellman is notable for discovering the Alpine Fault that runs the entire length of the South Island.